What are time and space do? We exist in space. When you hear the phrases time and space, you probably think of galaxies, stars, planets, aliens, and other cosmic objects. But what do these two phrases mean? What exactly is space? What exactly is time? Let's see if we can figure it out. We know the universe is enormous and unending. Furthermore, it is always growing. This universe contains us. We live in space, but there is also a beginning and an end. In other words, we only have a finite amount of time on this planet. What can have both an end and no end? In this video, we will attempt to answer at least some fundamental issues concerning space and time. Let's start with: so, what exactly is space? The concept of space is inextricably linked to the concept of time. Let us begin with a definition of this critical term. Space is simply the environment in which everything exists. This is the universe, complete with all of its stars, planets, galaxies, comets, and asteroids. Astronomers discuss the observable universe. That's what they call the area of space that we can observe and study with telescopes. The diameter of the observable universe is approximately 92 billion light-years, which means that a light beam traveling at the speed of light would take 92 billion years to travel from one side to the other side. Because the observable universe is so vast, it is difficult to talk about its limits. But as far as our solar system is concerned, it resides in the Oort cloud, which is a vast spherical cloud of comets extending about 1 light-year from the Sun beyond the Oort cloud. Our other spherical comets of clouds contain our neighboring stars. What is time? As we said, space is where everything exists. Time, in turn, is how we measure this existence. Time can be said to be the fourth dimension. However, it is ultimately not a place, but a measure of how long it takes for an event to occur. Since everything in the universe exists in space, time must also exist in space. The fact that we can measure time at all shows that it exists. When we talk about time, we more precisely mean the course of events in the universe and the counting of seconds, minutes, hours, days, and years. These are arbitrary divisions that humans have created for their convenience. They have no meaning either in the cosmos or the universe, but we all feel that time around us flows. Time is an essential part of our lives, both as individuals and as a species. That is why we have learned to master it and use it to our advantage. What is dark energy? Dark energy is a mysterious energy that is believed to make up 68% of the total energy content of the universe, while matter makes up only about 30% of it. Dark energy is believed to be the reason why the universe is expanding and also to be the cause of accelerated expansion. We still don't know exactly what it is. We don't even know if it's a particle, a field, or something else entirely. This is because we are currently unavailable to detect it directly. However, we can observe the facts of this dark energy in the universe. For example, we know that it is accelerating the expansion of the universe because astronomers can observe the expansion of different galaxies and see that the rate of expansion increases over time. The speed of light. The speed of light is 299,792,458 meters per second. It is the faster speed at which something can move in space. Therefore, it is also the fastest speed at which two places in it can be connected. Light travels at about 300,000 kilometers per second. That's about 9 times the speed of sound. But what does that matter? Light travels at a certain speed. And since everything in the universe, including space itself, is made of matter, everything takes up some space. This means that light takes time to travel from one place to another. Even when the start and end points are right next to each other, slowing down and increasing mass. The speed of light is constant and has no relation to the speed of objects moving in space. But if we travel at a speed close to the speed of light, then our clocks will slow down and our mass will increase. This is known as time dilation, and mass gain is because of relativity. In other words, it's our space and the speed of light affects time and how matter behaves in space. According to Albert Einstein's special theory of relativity, light travels so fast that in a vacuum, nothing in the universe is capable of traveling faster than it. However, if we travel very close to the speed of light, then for us time to slow down and our mass will increase. That would mean we should age more slowly with our space and time together. As we said, space refers to the environment in which everything exists, and time is the measurement of events in their sequence. Space and time are intricately linked and form a whole called space-time. This term was coined by Albert Einstein and is a useful way to look at the relationship between space and time. It is much more than the 3 dimensions of space. It also includes the dimensions of time. This means that there are 10 dimensions of space-time. An easy way to imagine space and time is to visualize them as a kitchen table, space as the tablecloth, and time as the table itself. According to Einstein, however, space and time are not 2 different things. They are a single 4-dimensional fabric called space-time. The fabric of space-time is extremely dynamic. It can bend and stretch, warp and pulsate. It can even tear and fall apart, as we'll see in a moment. But compared to an ordinary tablecloth, it is much more dynamic and also much more complex. How are space and time related? Einstein's general theory of relativity describes how the distances between objects change depending on their location in the fabric of space. Time objects that are far apart are connected by a twisted space-time thread. This is why the distances between objects can change even when they are not moving, because they are pulled by the gravitational field of other objects in space-time. The easiest way to understand the idea of dynamic space-time is to start with an example. Imagine that a bowling ball, which is a very massive object, is sitting on the blanket of space-time. The ball pulls the fabric down and makes a dent. It is located on the sheet of space-time, which is perfectly flat. In this case, the recess will be perfectly round. Why does the distance between objects change? The dent in space-time left by a massive object is something like a gravitational dent. It is a place where space and time are deeper than elsewhere. The hole left by the bowling ball makes the space-time around it a little bit shorter. The blanket of space-time does not slide down. It just shrinks slightly as gravity wells are deeper than their surroundings. The distance between nearby objects increases. It is like the difference between a mountain valley and the surrounding hills. The valley is lower than the highlands, so the 2 previously closed places are further apart. Why do objects move at different speeds? According to Einstein, space-time is not just a static blanket. It is also dynamic like a flowing river. Massive objects create eddies that slow down nearby objects while the flow pushes them forward. The flow of space-time around an object is called its acceleration and is measured by something called the space-time interval. Spatial temporal interval is kind of like distance, but it takes into account the fluid nature of space-time, so it is more complex. It is easiest to imagine it with an example. Imagine again a massive object like a bowling ball. The vortex it creates in space-time pulls nearby objects into the flow, and the space-time interval is the distance these nearby objects are carried around distortion of space and time. Sometimes the flow of space-time changes in more extreme ways. For example, when 2 black holes merge the fabric of space, time pulsates and tears, creating gravitational waves that travel through the universe. Gravitational waves are space-time itself, rippling like a flag fluttering in the wind. However, unlike the flying space, time is dynamic. It changes and flows like a river. As a result, it can change a permanent record of events, such as the moment when 2 black holes collide. There are many other ways that space-time can change besides gravitational waves. For example, a nearby supernova can create a huge gravitational well that bends and distorts space and time around it. Universes with different properties of space-time. All of this is important because it shows that space-time is dynamic, not static. It moves and changes all the time. The fabric of space-time does not just sit there like a tablecloth. It is like a flag waving in the wind. The fabric of space-time is the wind, and the wind is the universe itself. This means the space-time itself is what is expanding. It expands like a growing ball of yarn that gets bigger and bigger. To see how critical this is, consider what would happen if space-time were not dynamic. If the tablecloth did nothing but stand there like an ordinary tablecloth, this implies that everything else must revolve around it. If you've been following this video since the beginning, you'll know that the concept of space-time is highly complex and has perplexed scientists for many years. It is also a very interesting idea that is worth spending some time learning about. And who knows what else? It may motivate you to pursue a career in science. Let us know what you think about immortality in the comments. Would you want to live forever? Do you think it is right to change our nature to such an extent as to put an end to the death of old age? Thank you for sticking to the end. If you enjoyed this video, please do well to like it and also tap on the subscribe button for more delightful videos like this.